Hello children, how are you all? Hope so you are doing good. Yes, all of you are preparing very rigorously for your upcoming maths exam. That's very nice. Right. So in the today's video, I'm dealing with the concept of loci. Loci is a very simple and easy chapter, children, which will make you to get good marks in the exam. So only the thing is you need to understand the method of drawing the locus of a point. So first of all, let me explain what is the meaning of the term loci. Okay, loci is a plural form of the term locus. So what do you mean by locus? Locus is nothing but a location of a point. Okay, so you might have observed a pizza guy coming to your home to deliver a pizza. You'll be observing the path traversed by that particular delivery boy while coming to your house. So that path traversed by the delivery boy tells us locus of that guy clearly. So here also, if there is a point A, if point A is moving around like this, okay, so now finally it comes to point B over here. So the locus of the point A is nothing but the red line whatever I have drawn over here. So red line depicts the locus of the point A to reach from A to B. Clear? Very simple term, children. Very simple concept. So now suppose if I am asking you to draw here, majorly three cases come. Okay, so what is case number one? Case number one is what? To draw locus of a point which is equidistant, equidistant from a point. So when you are defining circle, we define circle such a way that if you imagine there is a point over here, I need to draw certain collection of points which remain equidistant from the single fixed point O. Okay, so how can I draw the collection of the points? I will always draw the collection of the point such a way that it goes in this point. So all the points on the circumference of the circle, you can take any point A here or B here or C here, all of them are at equal distance from the single fixed point, and we call that single fixed point as the center of the circle. So here, to draw the locus of a point which is equidistant from a single fixed point at a distance of at a distance of 3 centimeter, meaning what? You need to draw a point over here O and take 3 centimeter in your compass and draw the circle. So any point on this circle denotes locus of a point which is equidistant from the single fixed point O. Clear? So then the case 2, very simple, children. If I want to draw the locus of a point from two single fixed points, okay, right? So now here there are 2 points A and B. If I want to draw the locus of a point which is equidistant from these 2 points, so connect these 2 points and draw the perpendicular bisector of the line connecting A and B. So any point on PQ is the locus of a point which is equidistant from 2 points A and B. Because suppose if I consider a point over here, if I consider the point C, right, if I connect A to C and B to C, it will be a isosceles triangle, correct? So any point for that matter, all the points on this perpendicular bisector PQ depicts the locus of the point which are equidistant from A and B. Clear? Right, that is about the case 2. Right, so next one is a case 3. Case 3. What is case 3? I'll be giving you to draw the locus of a point which is equidistant from 2 points AB and BC. Clear? See here, this is nothing but a line segment AB and this is BC. Now there is an angle formed between AB and BC, that is nothing but the angle B. Okay, if you draw the perpendicular bisector of if you draw the angular bisector of this angle B, okay, any point on this angular bisector depicts the locus of a point which are equidistant from the two arms of the circle AB and BC. Clear? Right. So what are the three cases? The case number one, to draw the locus of a point from a single fixed point, you have to draw the circle. To draw the locus of a point from two distinct points, then you have to draw a line connecting that two points and draw the perpendicular bisector. Any point on this perpendicular bisector is the locus of the point which is equidistant from A and B. To draw the locus of a point which has equidistance from two line segments, then you have to bisect the angle between that two line segments, right? So any point on the angular bisector of this angle is locus of a point which is equidistant from these two rays which form a particular angle. Now let us see some of the examples. Now see children, this is a first example. I have taken a question from the sample paper 2025. The question says use ruler and compass only for the following question, taking scale 10 meter is equal to 1 centimeter. Okay, so here the scale is given to you as 10 meter is equal to 1 centimeter. Clear. A park is in a city which is bounded by straight fences AB, BC, CD and DA. Given that AB is 50 meter, so it is given to you that AB is equal to 50 meter, that is nothing but 5 centimeter. Then BC is equal to, it is given to you, BC is equal to 63 meter, that is a 6.3 centimeter. Then angle ABC is equal to 75 degree. Clear. D is a point which is equidistant from the fences AB and BC. BAD is 90 degree. So now what I do here is first I will draw AB. Now I need to draw the field here. So I will draw AB 5 centimeter. Now let me take the scale. So I will draw AB as a 5 centimeter. This I will call it as AB. This is B, this is A, I will call. Then BC is a 6.3 centimeter and angle ABC is a 75 degree. So now at B I need to construct 75 degree. All of you know that how to construct 75 degree children. To construct 75 degree, first I will construct 90 degree, then bisect the angle between 90 degree and 60 degree, that will give me 75 degree. Okay children, so now here I am constructing 75 degree. Now this is the 90 degree line. Now I need to bisect the angle between 90 degree and 60 degree to get 75 degree. This is 90 degree and this is our 60 degree. So this will give me 75 degree. Okay, so angle B is a 75 degree. BC is 6.3 centimeter. So now I will measure 6.3 centimeter in compass because BC is 6.3 centimeter. 6.3 centimeter. So I'll keep it at B and cut this 75 degree line. So this will give me C. Okay, BC is a 6.3 centimeter. Now after this what I'm supposed to do, and what else, BAD is 90 degree, they have given BAD. So BAD is 90 degree, so I'm supposed to construct 90 degree here because the angle BAD is 90 degree they have given you. So this is 90 degree. Very simple concept, children. Okay, it is very scoring. Usually whenever they are asking the questions on loci, they'll combine the construction on circles, then the loci. Okay, it won't, very rarely the alone concept of loci will be asked. Okay, it will be always combined with the concept of circles. Okay, so this is the 90 degree line. Okay, since they are telling you that angle BAD is 90 degree. Okay, so BAD is equal to 90 degree. You can see the question. So now what they're asking you is D is a equidistance from the fences AB and BC. Okay, see now D is somewhere on this line, AB is this, BC is this, D is somewhere on the angular bisector of ABC, because just now I explained, whenever you want to draw locus of a point whichever is equidistant from the two lines, then the locus of a point always lies on the angular bisector. Now I need to draw the angular bisector of angle B. Why only angle B? They are telling that the point D is equidistant from AB and BC. See, AB and BC. So B is the point of intersection. That is how you need to identify. I need to bisect the angle B to get the locus of the point which is equidistant from AB and BC. Clear, children? So I will draw the angular bisector. I will draw the angular bisector. Then I will extend this angular bisector such a way that it is going to meet the 90 degree line. Okay, look at this. Here it is given to you. It should go exactly with the point of intersection there. Okay, yeah, so it should go exactly over here, children, exactly here. Now it is the point D. Clear? So also locate the point P which lies on BD. Okay, so first locate D. What is D? The D is equidistance from the fences AB and BC. Okay, D is equidistance from AB and BC, and BAD is 90 degrees. So now this is nothing but the rectangular, okay, park, whatever I'm supposed to get. Okay, so after that, construct outline of the park ABCD. Also locate point P on the line BD. Okay, for the flag post which equidistance from the corners A to B. So now I need to draw the locus of the point which is equidistance from B and A. So I told you, whenever I want to draw the locus of the point connecting equidistance from two points, I need to draw the perpendicular bisector of that. I'll take the different colors so that it will be easy for you. Take more than half, then draw the perpendicular bisector of AB. Now don't change the length of the compass, keep it at this point and draw one more arc to cut the earlier one. So this is the line what I require now. Okay, so this is the locus of the point which is equidistance from A and B. So now the point what I require is here. Okay, this is the point what I require P. This is the point what I require P. Clear, children? So it says P lies on the line BD for the flag post which is equidistance from the corners of the Park A and B. A and B, it should be equidistant. So I can just name them as M and N, and don't forget to write over here. What are you going to write? Any point on any point on Mn is locus of a point equidistant from A and B. Clear? And also you should write any point on BD is locus of a point equidistant from AB and BC. Clear, children? This is the construction what you require. Clear? Yeah. Now let us see the second question. So second question says that using ruler and compass only, construct a semicircle with diameter BC 7 centimeter. Now I will draw a line over here which is 7 centimeter. The 7 centimeter is the diameter of the circle. So this I'll just call this as A and B. So I need to draw the semicircle, means what? I need to identify where is the center. So center to be identified by drawing the perpendicular bisector. Don't simply just locate the center of AB. You have to draw the perpendicular bisector of the line AB. Same procedure you need to follow, children. Take more than half. Don't change the length of the compass. Keep it at A. Then again you cut the arc whatever you have drawn earlier. Okay. So now you can observe that this is the center. This is the center of the circle. I need to keep the compass at O. Adjust the length of the compass so that the pencil is passing through B and A. Now I am drawing a semicircle. This is the semicircle. Clear? Okay. Now let us see the question what they are asking. Using ruler and compass only, construct a semicircle with diameter BC equal to BC they are telling. Okay. So now B, and I'll call this as C. Okay. BC equal to 7 centimeter. Locate a point A on the circumference of the semicircle such that A is equidistant from B and C. Okay, so you know that any point on the perpendicular bisector, this is MN. Here I can say that any point on MN, is locus of a point equidistant from B and C. You can say Mn is a locus of a point equidistant from B and C also, doesn't matter. So now I need to locate the point which is equidistant from B and C and lies on the circumference. So here is the point. Should I name it with particular letter? Locate a point A. Yes, they are asking us to name it as A on the circumference of the semicircle such that A is equidistant from B and C. Now complete the cyclic quadrilateral ABCD. ABCD is a cyclic quadrilateral. So I will connect in the order A to B, B to C, C to D. I need to connect. Now I need to identify where is D such that D is equidistant from AB and BC. Now see here. So AB and BC. See what is the common letter over here? Common vertex is B, right? Whenever two rays comes like this, I need to identify the common vertex and bisect the angle which is formed at B. So now I will draw the angular bisector of angle B, because I need to identify where is the locus of the point which is equidistant from BC and BA. Okay, so I will draw the angular bisector. So I will just connect this angular bisector with D, which goes and meets the semicircle at D. So this is the required point. So now ABCD is nothing but the required cyclic quadrilateral. Why I'm calling it as cyclic quadrilateral? Because the vertices of the quadrilateral lie on the semicircle. Clear? So again I need to write over here. What should I write? I should write that any point, don't forget to write this one, any point on BD is locus of a point equidistant from BC and BA. Clear? Okay. So now ABCD is a required cyclic quadrilateral. 4 marks, children. 4 marks. Clear? Right. So now how the marks are allotted? Let me tell you the allotment of marks. First of all, drawing the semicircle and perpendicular bisector, that will give you 1 mark for the method. Then later locating the vertex D, okay, on the semicircle will give you 1 mark. Okay, then completing the cyclic quadrilateral will give you 1 mark, and the explanation of the loci will give you 1 mark. Okay, this is how the marks distribution happens. So now let us see the next question, children. Question number 3. Now let us see question number 3. What is question number 3 says about? Use ruler and a pair of compass to construct a triangle ABC where BC is equal to 4.2 centimeter. Now I will take the compass. BC is 4.2 centimeter. I'll just directly draw this line BC. So I just name this as B and C. It is 4.2 centimeter. ABC is 60 degree. Angle B is 60 degree. Very simple one, children. Need to understand very carefully. Okay. This is the required angle B, which is 60 degree. I am going to draw it now. So this is 60 degree. Okay, so 60 degree. Then AB is equal to 5 centimeter. Now I will take 5 centimeter in the compass, that is AB. AB is given to you as 5 centimeter. So B I have already located it. Now my task is to locate where is A. This is A. Okay, so this is A. Now if I join this, I'll be done with the triangle ABC. Now see the next part of the question. ABC. Consider a circle of radius 2 centimeter to touch both the arms of angle ABC of triangle ABC. Okay. So both the arms of angle ABC, look at this. This is B, this is A, this is C. I need to draw a circle such that it touches the arms of the angle ABC, and it should remain equidistance of 2 centimeter. So means what? Radius of the circle should be 2 centimeter. Means what? It should be at a distance of 2 centimeter from AB and BC. Means what? It should lie on the angular bisector of angle ABC. So now I'll draw the angular bisector of angle ABC. Understand it very carefully, children. It's better to do along with me, okay, so that you can understand and you have the hands-on experiment. Okay, so now this is the required line. Okay, so I'll just call this one as a D. So I can write over here any point on any point on AD is a locus of a point equidistant from AB and BC. Now what they are telling, I need to draw a circle which is of radius 2 centimeter and which should touch AB and BC. So for that I need to draw a line which is parallel to BC at a distance of 2 centimeter. So I'll draw a 90-degree here. Anyhow, I have drawn 60-degree line. I'll just extend this line. 60 degrees already drawn over there. So 90-degree I will draw and bisect this angle. Then I'll keep the sharp edge of the compass over here. Then bisect this. This is the 90-degree line. Now it is at a distance of 2 centimeter. So 2 centimeter I need to locate a point because the radius of the circle is given to you as 2 centimeter. So now I'll take it as 2 centimeter. A minute change will give me the wrong answer. So be very careful when you are taking it, children. Pencil should be sharp enough. So you can do it in a better way. Since I'm doing it here on the screen, may not be a perfect one. So again, what are you going to do is you are supposed to construct 90-degree at this point. Okay, either you can copy this angle or better construct 90 degrees. It's your wish how actually you are going to do it. Okay, so you can construct one more 90-degree here or copy this. Already 90 degrees drawn there. You can copy that. That also can be done. Okay, need not be a circle. Can draw it on the other side also, so that all the arcs you should not get confused with. Okay, so this is what I'm going to draw 90-degree at this particular point. I can call this point in fact so that it will be easy for you. This point I'm calling it as P, this point. Okay, so the 90-degree, why I'm doing 90-degree you need to understand, because co-interior angles are supplement of each other. 90 plus 90 is 180 I should get, or interior alternate angles are equal to each other. See, this is the 90-degree line. Whatever I'm drawing over here, I'll extend it like this so that it goes and meets the angular bisector of ABC. So I have to draw a circle which is at an equal distance of BC, equal distance from BC and AB, and it is of the radius 2 centimeter. Now if I take the radius as 2 centimeter, so now I'll get to know whether I have done accurate construction or not. Okay, so let me check whether it is touching the sides, okay, AC and AB or not. Okay, so it is touching the two arms. Okay, if you observe carefully, see, look at this, it is touching. Yes, okay, look at this. This is how the construction is supposed to be. A minute, it is overlapping. In fact, it should touch exactly like this. Understood? Okay, so this is how the locus of the point which is at a distance of 2 centimeter means what? Perpendicular distance of this point. If I call this point as O, so if perpendicular distance of the point O from BC and perpendicular distance of the point O from AB is same, that's why you are getting a circle which is radius 2 centimeter and touching arms of the angle ABC. Yes, children. So similarly you can do many of the questions. Easy chapter don't have the block that LOCI is a very difficult chapter. Okay, I have shown you few and you can try some more question. I hope so this video is very fruitful. Don't forget to subscribe and like and also share the video with your friends. Thank you so much.